Okay, we're going to look at how to add vectors today, which we did in some really basic cases already. Recently in class, we've been adding or subtracting two vectors that were along the same axis, and if that's the case, it's extremely simple. For example, if we have somebody pulling at 50 newtons this to the right, and then a second person pulling at 100 to the right, if they're along the same axis, it's just their algebraic sum, which would be a total of 150 newtons. So we don't need any special methods for that. Similarly, we've done some problems where we had a person pull to the right and then maybe a person pull to the left, like in a tug-of-war situation, again being on the same axis. And elevator problems we've done kind of did the same thing vertically, and still it remains kind of simple. If this is 25 newtons to the right and the other person pulls at 10 newtons to the left, then the resultant, as we call it, the resulting pull is simply the difference between those, which would be 15 newtons to the right. So again, that's simple stuff we already did, but we're now going to look at vectors in two dimensions, which we'll start out with the most simpler case, and that's when those two vectors are perpendicular, or meaning they meet at a right angle. And we're going to use a method we're going to call the head-to-tail method. I don't know where my D went there. Alright, so anyways, when we have two vectors that we need to add, two or more, that don't lie on the same axis, we just can't add up their numbers simply. So it's kind of like thinking, we'll use forces most of the time as our examples here, but it could be any vectors, whether they're velocity or displacement, anything that has magnitude and direction, but I'll be using forces for the bulk of these examples. Let's say we have a point that two things are pulling on. Somebody's pulling with a force to the right, we'll make that one blue, and then somebody's pulling with a force upward on this object. And let's get some numbers involved in this. Let's say the pull to the right is 10 newtons and the upward pull is close to the same, about 12 newtons. If I say, add their vectors now, you can't simply just say 10 plus 12. They are not on the same axis. So what we have to do is use something called the head-to-tail method. And it's called that because we're going to shift it to draw in the resultant so we can see it graphically. So what we're going to do is we're going to take this vector right here in red and shift it down its tail to the head of this blue one. So I'm going to get rid of it here. Now this is what's really happening, but I'm going to erase it. And I'm going to make that red vector here now. And graphically this is how we do it. So it's still 12 newtons, but it's now over here. And why we just did that is to draw in the resulting vector. And that's going to be from where the first vector started to where the last one ended. And this is a convenient situation because if you notice, they were perpendicular, and they still are when I shifted them. So that makes this a right angle, and this is a right triangle. So this is still 12 newtons right here. We'll just move that over. And now our magnitude of the resulting force of the two pulling at once is going to be, let's refer to it as F sub r, the resultant force. And this will figure out our magnitude, and it's really just need the Pythagorean theorem to do that. So the resultant, whether it's a force or a velocity, if it's a velocity we'll do V sub r, if it's a displacement we might do D sub r, our typical, will be equal to the square root of the square of the legs. Easy Pythagorean theorem stuff. So we evaluate that, take their square roots, and let's see what that comes out to be. Oops. And we'll round it to one decimal place. It will be about 15.6 newtons. So what that tells us is if two objects pull on one spot, this being the spot, one was pulling to the right and one was pulling this way, then the object is going to move somewhere in between there, and it will be moving at this amount. Notice that amount is nowhere near equal to what 10 plus 12 would be, so you can't straight up add them, you can't straight up subtract them. We have to put the tail of one on the head of the other to form the triangle, which then shows us clearly, because it's a right triangle, to do the Pythagorean theorem. Now often we also want not just magnitude but direction. The direction is going to be this angle here. We typically find direction as the angle between our resultant vector, this green one, and the x-axis. So right here is going to be the angle we want, and we just use basic SOHCAHTOA to do that. Usually, since we have all sides of this triangle, we could really use sine, cosine, or tangent, but to limit it to using only givens, that would lock us into tangent. So this could be called alpha, theta, whatever. Doesn't matter. Usually we give some kind of Greek letter symbol for angles. So tangent alpha will equal 12 over 10. And then we'll take the inverse tangent of that value to find what the angle alpha is. So inverse tangent 12 over 10. And making sure we are in degree mode, that's a real common problem. So make sure you don't make that mistake. We're going to get about 50.2 degrees is the angle in that quadrant. I'll talk more later in the next method when they're not perpendicular how we might need to be a little bit more specific about that angle. But for a basic example, that's pretty good. So we now found both the magnitude and the direction of the pull resulted from these two perpendicular vectors, one to the right and one up. That's the direction it will go in, and that's a pretty important thing to find in a lot of situations. You have multiple pulls on an object, where will it go, where it will move, where will it end up, and you cannot just simply add up the two numbers or subtract the two. You've got to do vector addition when they're on two different axes.